Welcome back, guys. Happy New Year. It's the first video of the year. We already went over in class today the basics of ellipses, and so this video is going to show you how to take some characteristics of an ellipse and change it into the equation. We're going to be writing the equation for the ellipse. For these problems, especially in the beginning, I still recommend drawing the ellipse or graphing it as you go. And even though we already went over it, I'm going to rewrite for the for ease of this video, the standard forms for an ellipse. So the standard form for an ellipse is x minus h squared divided by a squared. Remember, a is the distance from the center to the major vertice plus y minus k squared over b squared equals 1. Okay, and this is the form for a horizontal ellipse where the major axis is running in the horizontal direction. If the ellipse is running the other way, like this image down here it would be, then you just simply switch the a and the b, or you can think of it as switching the y and the x. Doesn't really matter. But generally the form would look like this: y minus k squared over a squared plus x minus h squared over b squared equals 1. Okay, so in these examples we're going to be given different characteristics of the ellipse, and we're going to use those to solve for the center. Remember, the center is h comma k. And then we're going to need to solve for a and b, a being the distance from the center of the ellipse to the major vertice in this handy picture here, and b being the distance from the center to the co-vertice, okay, on the minor axis. Okay, so for a here, they describe the major axis as going from one point to another. So we're going to plot these 2 points, negative 6, 2 and negative 6, negative 8. Negative 6, 2 would be right here. Negative 6, negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, and just by knowing that these are our major vertices, we'll label those with V's, we should be able to find the center of our ellipse, okay? Regardless of whether or not we know what the minor axis is, we know that the midpoint between these two vertices has to be the center of our ellipse. Now you can either count if you have your graph, or you can go ahead and just take the average of the y coordinates, right? The average between 2 and negative 8 would be negative 3. So we know it's going to be here at negative 6, negative 3. That's the midpoint, and that's our center. So now that we have our center, I'm going to write that coordinate, negative 6, negative 3. Because that's going to be important. That's our h and our k for us to write it in standard form. But we're going to need to use our minor axis to help us find the b for our standard form. So I'm going to plot the minor axis coordinates, negative 3, negative 3. And negative 9, negative 3. Okay, and these are our co-vertices, so I'll label those as CV and CV. And then now we can go ahead and graph our ellipse. Okay. Now, if you look at your handy chart over here, you'll see that A is the measure from the center to the major vertice up here. So A would be the distance from the center up to this vertice. You can count 1, 2, 3, 4, 5. A is going to be 5. And B is the distance from the center to the co-vertice, which is 3. B is 3. And now we're ready to choose. Make sure you pick the right form of the standard form of an ellipse. Since this is a vertical ellipse, because my major axis runs from top to bottom, I'm going to use this second equation with y being over our larger side. Okay, so just imagine, since a is larger, it's going to be underneath the y coordinate. So our final answer will be y minus k. K was negative 3, so y minus negative 3 squared divided by a squared, 5 squared, plus x minus h, that would be x minus negative 6 squared over b squared, which is 3. Okay, and we'll clean this up a bit for our final answer, so we get y plus 3 squared over 25 plus x plus 6 squared over 9 equals 1. Okay. They could give you different parameters. They don't always have to give you the major axis and the minor axis. They could start including the foci, like in our next example. Okay. The foci, as we talked about in class today, are always along the major axis, and we use the parameter c to measure the distance from the center to the focus. A lot of people try to measure it from the vertice when really it needs to be measured from the center. That's a common mistake. So make sure you make note of that. When we find c, that's always going to be our distance from the center to the focus. So let's go ahead and set up our coordinate axis here. Our vertices are at -4, 4, and 6, 4. So I'm going to need to be up above the axis. So I'm going to set my coordinate grid so I have plenty of space up above the x-axis. The vertices is at -4, 4 and 6, 4. 1, 2, 3, 4, 5, 6, 4. Label those my major vertices. And they didn't tell us anything about the minor axis, but they did tell us that the foci are at -2, 4 and 4, 4. Okay, and it's important that the foci should be the same distance away from the center, just like the vertices are the same distance away from the center. So you can think of it two ways. Since we're already graphing it, we could just count to see where the midpoint would be between the vertices and the foci. Or if you want to do it algebraically, you could just find the average between -4 and 6. The average between -4 and 6 is 1, so that lets us know that where our coordinate is going to be 1 over. You could also just use your midpoint formula. But there's going to be our center. And the coordinate for the center, we're going to write that out. The center coordinate is 1, 4. And again, that's going to be our h and our k, which is going to be important when we write the equation. Now, we need to figure out what a and b are. Unfortunately, we don't know anything about the minor axis. We do know a, though. A is the major axis. It's the distance from the center to one of the vertices. And I can count that really easily. That's 1, 2, 3, 4, 5. It's 5 units away from the center. And we also know c, the distance from the center to the focus. Remember, you want to measure from the center to the focus, not the vertex to the focus, but from the center. The center to the focus would be 3 units, so c is equal to 3. Okay. Now, there is a relationship between the distance from the center to the focus, the distance from the center to the vertex, and the distance from the center to the minor vertex on the minor axis, or co-vertice, I should say. And that relationship is kind of counter to what we are used to writing. It's c squared plus b squared equals a squared. And so it's kind of a messed up Pythagorean theorem. We're used to saying a squared plus b squared equals c squared. In this situation, a is your largest side. Remember, that's your major axis. So a is going to be acting as the hypotenuse. B and c are the shorter sides. Those are the two legs. So don't let the names of the lengths confuse you when you're trying to set up this equation. So we can solve for b. We can solve for how long the distance is from the center to the minor vertice by using this equation. So I'm going to plug in that c is 3 and a is 5. And if you're used to solving with Pythagorean triples, you might quickly realize that b is going to be 4, because you'll see that b squared equals 16, and so b is 4 units long. And so that's important. That tells us the distance from the center to the minor vertice. So I can count up 1, 2, 3, 4. There's my minor vertice there, or co-vertice, I should say. And then 1, 2, 3, 4 down here. That's your co-vertice down there. So we can go ahead and graph our ellipse. And again, graphing the ellipse is not the main goal for these equations, but I still say it's helpful, especially in the beginning when you're not used to what these parameters look like or do, to draw the graph each time, to plot the focus in the center if needed. So now we're just going to write, this is obviously a horizontal ellipse, so we can see that from the graph, and we can tell that our major vertices were aligned horizontally. So we know this is going to be using x minus h squared over a squared. The a is the largest one, it always goes with the dominant axis, and then y minus k squared over b squared. That's going to equal 1. And so since we have our center, we know h and k, we know that h is 1. We solved for a in the beginning. A is 5, and 5 squared is 25, plus y minus 4, since my center is at 1, 4, over b squared. B we solved for was 4. 4 squared is 16, equals 1. So that is our standard form for a horizontal ellipse, okay, given the foci instead of being given the covertices. Okay, here are 2 sample problems that I want you to do, complete and turn in tomorrow. Plot and write the equations for ellipses that have foci at 19,3 and -7,3. And this time they told you the length of the major axis. So if you know the length of the major axis, you would cut that in 2 to figure out how far from the center it is to your coordinates that are the vertices. Okay? If you graph this one, it becomes very apparent where the vertices are. And then it's just like the second example. Same thing here with 2b. This is like the first example we did. They give you the vertices and they tell you how long the minor axis is. You can figure out the center from these 2 vertices, and then once you know how long the minor axis is, you can just put, since it's 10, there'll be 5 units on each side of the center to find the covertices. Okay? I will put up the answers in a second for you to check. Okay, here are your final answers. I apologize for the size of the ellipse that I drew. In fact, I think I'm looking at it now, I actually missed the vertex on this one. It's supposed to be even bigger. There we go. The first one was quite large, took up most of my sheet. But you start by finding that the center is at 6, 3. You could find the midpoint between the foci, or you could just plot them and then count to the middle. You should get the center to be at 6, 3, which tells you h and k. And now you just need to find a and b. So you know that the distance from the center to the foci is going to be your c characteristic. That was 13 units. And then they told you that the major axis had to be 30 units long. So if the total major axis is 30 units long, then that means from the vertex to the center it has to be half of that distance. So that's how I got that a was 15 units long. Once I knew that, I could just count out from the center and plot my 2 vertices, and that helped me draw my ellipse. Then you could solve for b using c squared plus b squared equals a squared. Remember that a is the largest side now. When you solve for b, you get a decimal. You actually get the square root of 56, which is 7.5 approximately. So I approximated the covertice to be about 7.5 units below and 7.5 units above the center. And that's how I got my giant ellipse that you see there now. However, when you're plugging in numbers, you don't want to plug in the approximation. You want to plug in the exact value for b. It actually works out nicely because you end up squaring the square root of 56. So when you plug that in, you actually just get 56. So this should be your final answer for the equation of the ellipse for letter A. And letter B was actually a lot simpler, was smaller to begin with. And the vertices at -2, -4, and -2, 8, their center point was going to be at -2, 2. And then when you solve for A was 6. However, this was a vertical ellipse, right? It was longer up and down than it was left to right. So we're going to reorder our equation. It's y minus k over a squared. So I got y minus 2 squared over 36 plus, and then you put your x component over here over b. So it was x plus 2 squared over 25. A and b were a lot simpler to find in this one because they told you the exact locations of the vertices, so you could just count from the center to the vertices. And then they also told you the minor axis was 10 units long, so that meant b had to be half of that, 5. Okay. We'll go over any other questions you have in class tomorrow. Hope you guys have a great night.